Welcome everyone. Today we have our another new episode and we will discuss on cloud computing. And we have our world famous speaker, Professor David Smith and Professor Rob. Thank you for joining today's session. First, I would like to give chance Professor David Smith.
It's a very good topic today, Sharif, and particularly as you look at where we are in our time. 'Cause it's really cloud computing virtualization, and particularly during the last 2 years, virtualization and cloud computing have both played a extremely significant role uh, during the COVID and the other activities around it. Because what they did is they allowed businesses to adapt to the lockdown by rolling out reasonably secure remote working environments because most people were working from home. And they were able to do it on a short notice, which by combining these two technologies. Uh, you know, we are at a place that because of the experience during COVID, we're going to see this technology continue to go. And we're seeing a lot of people who are beginning to make the shift from traditional IT in an office to cloud and virtualization. Let's just take a minute and talk about virtualization first. Virtualization uses software to create an abstract layer over computer hardware that allows the hardware elements of a single computer, processes, memory, and storage to be divided between multiple virtual computers, commonly called VMs. And each VM can run its own operating source system and behave like independent computers, even though it's running on a single piece of hardware. One of the real interesting things with virtual computers is it lets us begin to handle our security in a different way. For example, on my mobile computing devices, I run virtual machines. And depending where I'm working, I might run a virtual machine because of security consideration. Uh, some of the agencies I've worked with in the past, they put virtual machines on their smartphones so that they can have a secure area on the smartphone that's independent from the network access and from the underlying operating system. So you see them in many different places. Uh, but there's often mistakes, though. People like to compare cloud computing and virtualization. But when you really think about that, it's like comparing apples to watermelons. They're just not the same. They're just not there. And you see a virtualization system that I can run in my own data center. I can run on my servers. I can run it on my own PCs. Like I said, I can run it on some of my mobile devices as well. So they really are different. And I can create and use virtual servers, virtual desktop, virtual applications, and I can continue that path going forward. To build a cloud environment today, though, they are usually dependent on virtualization. The clouds that we've built in our own data center, we run multiple virtualizations on each of our servers to create different environments, different test beds, different QA, different development environments, and even use virtualized remote desktops to access them to add into the security. Uh, but let's just take a minute and talk about what are the different types of ways we can produce that. There's different types of virtualization you've heard me mention. There's server virtualization, there's desktop, there's application virtualization. There's a category of virtualization called data virtualization, and this is done several ways today. And it's where data is segmented, arranged, and delivered without the end user needing to know where the data is. And this is one of the ways where data virtualization has helped with security. Also, data virtualization and storage virtualization often are done with a federation manager, which allows you to use multiple data types, multiple databases, multiple data things, and be able to adapt them into another concept called network virtualization, where it's a software based way to put networks together. And what are some of the benefits of virtualization in the cloud? It reduces cost, it improves security, it enables you to have some speed of innovation as you can rapidly spin up and provision these virtual cloud environments. It enables rapid and frequent testing because it's easier to run the test in these virtual machines than it is on a physical one. Because if a virtual cloud environment crashes, it doesn't bring everything else down around it. It really simplifies disaster recovery, and it lets you look at different ways to segment your resources and to be able to connect your resources in ways. And it's also easier to look at it as an ease of access to it because a virtualization machine on a cloud computer really is just a software representation and it's not the hardware. So that helps you as you look at cloud computing virtualization. But Sharif, I think that's a quick first step. I can't wait to hear Rob.
Thank you, Professor Rob.
Well, virtualization's interesting on a couple vectors. One is it was created initially to overcome a problem, and that problem was the changing chipsets that were occurring under Intel's platform. Virtualization allowed for a standardized hardware, a seemingly standardized hardware framework upon which you could build a much more consistent software stack. And so in a way, and that's what made Pat Gelsinger going to VMware so interesting years ago, was Pat Gelsinger was part of Intel when they had the rapid changeouts of chipsets, which caused significant problems every time it occurred because the software that was written for one chipset wouldn't always work well at all on the succeeding chipset. So virtualization was seen as a way to solve that problem by creating a virtual machine. You could standardize on the virtualization layer, and that way the software above it could remain constant. And of course that was seen as a good thing. The downside was you took a performance hit, and so it kind of rumbled around for a bit until we came up with what we're calling Web 2.0, which is this focus on the cloud. Be aware that we've announced, at least the industry's announced, Web 3.0, and that's the metaverse. So we'll get to that in a second. But in Web 2.0, you live in the cloud, and now these virtualization layers, they're used to emulate machines in the cloud. So you don't have to have a dedicated server. You don't have to have a dedicated PC, depending on what you're virtualizing. You can create a virtualization layer in the cloud and do it that way. And virtualization is different than emulation. Emulation allows one piece of hardware to appear like another piece of hardware, but it is not contained. And so in some ways it can outperform virtualization. In some ways it doesn't. It doesn't have the security benefits of virtualization, though. What virtualization does is it allows things like rootkits to reside above the core kernel, the core operating kernel of the hardware, and thus it can be discovered. Because the problem with rootkits on a regular PC is a rootkit can get down below the software level and down into the firmware level, and then antivirus software can't identify it. It sees that as just another part of the hardware platform, and treats it like it's part of the system. So it can neither identify nor remove a rootkit. That's why it's been so problematic when companies, and sadly Sony was one of the companies that did this years ago, released rootkits to try to deal with, in that case, music piracy. But in the end, virtualization kind of allowed us to do things much more consistently and with much less aggravation than using other methods. The other part that's kind of interesting is back when we first started large-scale computing, we had what we called mainframes, and mainframes were connected to terminals, and terminals were pretty much like televisions with one channel. Not much to them. You turned them on and you worked on them. I came up. Sadly, I started with PCs and I rotated back to terminals, and I hated them. But the one good thing is you powered them up and they just worked. You didn't have to worry about software updates. You didn't have to worry about security. You didn't have to worry about other than physical security. That you really none of the things we have to worry about today as users did we have to worry about it back then, because that was all handled by IT. And the issue, of course, with IT at that time, it was called MIS back then, was the fact that they didn't really view their users as anything but an unnecessary obligation, and so they weren't very responsive. And so if you wanted to get an application done, instead of going to the store or more recently going to the web and downloading it, you had to make a request. That request went into their queue, and maybe a year and a half or 2 years later, you got a response that might, if you were lucky, look something like what you requested. In my own case, it wasn't really close at all. So there's a tremendous amount of aggravation, and that's what kind of drove the entire PC effort. Let's put control of the applications in the hands of users and make it that way. But what we traded off was that centralized support, those economies of scale where a few people could handle all the aggravating stuff. And with a PC, all of us had to handle all the aggravating stuff, which again was kind of problematic. So since then, the industry has tried to pivot back to this mainframe-like structure, and Web 2.0 is very mainframe-like. It's rather than putting everything in the mainframe, you're pretty much putting everything in the cloud, or as much as possible in the cloud, and then somebody else handles all the fiddly bits. They maintain the servers, they do the software updates, and you only deal with whatever's in your little virtualized universe. And some of the problems that occurred early on were issues like cross-contamination of working spaces, where in a web environment, one container might get it. Well, it was before containers, but one environment might get infected by a virus, and then it would spread to all the other environments on that particular server. So then we moved to a containerized strategy where everything was pretty much isolated. And right now, in the cloud, if you get infected with a virus, or if somebody else on that cloud gets infected with the virus, it's very unlikely that anybody else gets infected, because everything is contained and virtualized. And so it does keep down the spread of malware, unless somebody goes after the service itself, and there lies where the vulnerability is because these things are big honeypots, so a lot of money, a lot of capability, a lot of secrets, all contained in these cloud servers. And so even though they've got a substantially more security than you or I could ever afford to put on them, they're also like a vault full of diamonds and money. They are hugely attractive to hackers, because if they can penetrate the structure, they can do a tremendous amount of damage across a large number of companies. And we've certainly seen the kind of impact that has when a service like AOL has a major problem, and suddenly eBay doesn't work, and PayPal doesn't work, and Amazon's own stores down. So outages, which used to be kind of contained to the server environment or the mainframe environment that controlled the company. Now outages can cover multiple companies at the same time. You can wipe out a good chunk of a country's electronic infrastructure by taking out a major cloud provider. And so that doesn't make them just attractive to criminal organizations. It makes them attractive to hostile states. And so a lot of work goes into securing these environments, but these environments are up against bad actors at a state level. And that makes them relatively, given the level of security that surrounds them, it still makes them relatively vulnerable because they're so attractive. And so in the end, it really comes down into when you're choosing a service provider, whether it be Google, AOL, Azure, whatever, you're looking pretty hard at how well they secure their environment, how easy is it and as a primary, and then how easy it is to use the service as a secondary. Because if you get breached and your infrastructure comes down, that's often a board level problem, and you really don't want to have one of those problems land back on your desk. And so you want them to be secure and take security seriously, but you also have to take security seriously, because you don't want to be the one site that did get hacked and penetrated because you didn't secure your own side of the environment. So this is kind of the world as it exists now. Web 3.0, we move away from the internet constructs and the cloud as we know it into the metaverse, and now we predominantly work on the user interface and change the user interface from what it has been, which is one where humans have to learn how to work with a computer, to what it's trying to be, and that's where the computer learns how to work with you. And that's going to be pretty interesting as it develops. We're at the front end of Web 3.0, and it's still as yet unclear how the metaverse is going to evolve. Companies like NVIDIA pushing really hard for an internet-like generic metaverse where you can move from company to company, much like we can move from website to website seamlessly, and everything works. However, some of the metaverses that are coming up, with Google and Facebook being examples, are coming up as walled gardens, very much like CompuServe and AOL did in the past, where you go into their environment and you live in their environment, but your ability to move between environments is somewhat restricted, either by the technology or by policy, because they want you to consume whatever the advertising content is on their service and not anybody else's, because that's how they make their money. In terms of capturing eyeballs, you might call this is kidnapping eyeballs and holding you hostage. Walled gardens, we have seen in the past, don't work well long term. That's why AOL and CompuServe failed. But they do have one big advantage, and that one big advantage is control. A walled garden can control its environment absolutely. Where if you are focused on interoperability and transport, it's those standards that will dictate a lot of what it is you can do, and that will restrict the amount of control you can place on your environment. Not as much as might have been the case 20 or 30 years ago, but it's still a restriction that companies don't appreciate. And more important, it's much harder to lock people into an environment when you're talking about an open architecture, because people by nature of the open architecture are free to move, and of course that movement means you can't assure yourself that the revenue is going to be there for the rest of your life. And MySpace and Facebook's trade-off is an example of that. The folks from MySpace moved over to Facebook. MySpace went, well, it's still around, but not happy, and ended up over Facebook, which is now a power in the industry. So in the end, this virtualized cloud environment that we find ourselves in today, Web 2.0, is evolving into something very different, and one that's going to be much more focused on the user interface and computers that interact with us as if they were more as if they were people than as if they were machines. So we're in what is probably one of the most interesting transitions in the computer space that has yet occurred.
Mm-hmm. Thank you, Professor Donald. Can you unmute, please?
Let me see if this works. Can you hear me?
Oh, we can't hear you. It looks like you're being hidden to preserve your anonymity.
No, it's because my microphone broke, so I can't do it today.
You can continue, no problem. If you discuss loudly, maybe
If you speak up really loudly, we can hear you. But it sounds like you're in a bathroom or a shower.
Well, I don't know if that's going to work very well, but I'll try. All I can say is, I mean, everybody's outlined it pretty well. When we basically, the problem that we're trying to solve is think about the idea that especially of earlier Macintosh, they ran on a chip that called a 68000, which was made by Motorola, and the Windows ran on a chip made by Intel. And their instruction set, the lower level machine code that you wrote the programs in were completely different. And so the compilers, the program that changed the high-level programming languages like Pascal and C and Algol and all the different languages they were using in those days, Fortran, and they use most of them. They don't use Algol anymore, but translated from the high-level language into the low-level language. So if you translated the high-level language into the low-level language for Intel chips, the programs wouldn't run at all on the 68,000 on the Motorola chips. And so what people needed to do was to write software that took the instructions from one chip and then sort of translated them into the instructions for the other chip. And that was what the early emulators were about. That was what they were for. And to this day, the emulators that run on Macs especially, and when you run Windows on, Macs have switched to using Intel chips, but the emulators, when you run Windows on a Mac, that's what they do. That's the point of them, is that there's a different chip on a Mac than there is on a Windows system. So it allows you to have a Windows environment on a Mac, because you can basically grab Windows and install it on a Mac, because the low-level instructions are translated from one to the other. And as Rob said, there's that extra step of translating. It does come at the cost of performance. When you look at the cloud, what happened when you're thinking of Amazon and when you're thinking of AWS, lots of people are using AWS at the same time. And if everybody was using it at the same time, you think of one way of doing it is when you're on Windows or Unix or whatever, you're allowed to give people different accounts. And when they have different accounts, they can use the machine, and they can't use each other's files if you set it up right, and they can run their own programs and things like that. And in the very early days of computers, that was how it worked. But it was very easy to get through the security of that. I mean, I knew how to do that. I did that all the time. And so that would be too much of a problem to do something like Amazon. So people started creating, using this virtual environment on the same kind of machine. So they would make not one virtual, they'd make a virtual environment that would work on an Intel chip, but what it did was it separated that from the other. So every time you log in, you wind up having your own version of whatever operating system that you need. So it could be, you can log in and it's a Windows, or you can log in and it could be Unix, and there's multiple instances of it. So there's basically as many as the computers can run without bogging it down. And then if you want more, you just add more computers. And that's what, if you went into Amazon, one of the Amazon buildings, there'd be a data farm or Google that's, the size of a massive coliseum with just computer after computer, actually not computer, but these racks of multiple computers after racks of multiple computers, and air conditioners to try and keep it all cool. And that's the technical thing of what virtualization is. Another thing that it's commonly used for is when you when you use Python, you basically, when you're creating a Python program, you usually create it in its own environment. So there's a Python virtual environment that you download, and it looks just like the Unix system that you're running on, if you're running it on Unix, or the Windows system that you're running on. And it has all the Python stuff and all of the Unix stuff that you normally use, but it's separated from other ones. So you can make each program in its own environment that's different than another environment. So it's the same thing, but the virtualization is running on your local machine instead of the cloud. Anything that you do is potentially, quote, on the cloud these days. So a lot of times what winds up happening is you store your files on the cloud because you don't want to use it on, you don't need to have so much disk space. And you want to have your files separated from everybody else's files. So it's what David said about virtual data, everybody's file system. So S3 on Amazon is a way of having a virtual file system, and each file system is separated from each other file system. And without virtualization, the cloud really wouldn't work. And that's basically, I'm just describing what it is, and that's all I'm going to say right now.
Thank you, Mr. Martley. We are discussing about cloud computing, so what you want to share with our audience here?
Just checking out and hearing what y'all got going on. Cloud computing, as many of the guests have already said, is very important because a lot of people are using the cloud in order to store a lot of their information. I remember back in the old days, we all had letters that we sent to our friends and family, and we love to collect those letters, just like we used to love collecting stamps and all of that. And now a lot of that information is in the clouds, and definitely that is a great place to keep it. We have to make sure that it's secure and all of that. I do know that one of the things that sometimes people have been getting frustrated by, and I don't know what the other panelists think about this, is that we have so much access to the cloud and so many emails and other things that we store and everything, and that can be great for historians and for even our own personal history and everything. But with it being so easy and so easily obtained and easily gathered, I don't know that we're collecting as much of the stories as we used to collect, because I know that a lot of times when people pass and we think about those great stories that they used to tell us and all of that, a lot of times they're buried in all of those emails, because a lot of times we have hundreds, if not thousands, if not the tens of thousands, if not hundreds of thousands of emails. So you may have that great story that your uncle told you or that your best friend told you that you might want to turn into a novel or just have as a family remembrance. But if you're trying to find that information, because the cloud is such a big cloud and we oftentimes have lots of information in that cloud, it can be difficult to retrieve the information. Because like I said, you might put in a search engine, Uncle Joe, if it was Uncle Joe's things that you were trying to find, and if you had 10,000 correspondences from Uncle Joe, you got to go through all those 10,000 to find that one story that you were looking for, and all along those lines. So while I am a big admirer of the clouds and the ways that the cloud is being used, I do sometimes wonder about the personal aspect of it and whether we are losing some of the interpersonal connection and also documenting. So I would urge people to do the cloud, but also maybe create some videos and other things of those family members that they would like to remember long before they are gone, or even friends or things along those spaces. And sometimes you can even put that in the cloud as well, because the cloud isn't just digital, or not just it's all digital, but not just written information. It is also information that could be video, audio, or a number of other things in that space. Because I've even heard some people that have old audio tapes of some of the great jazz legends and some of the great historical figures, and sometimes they go back through those records, find them, and actually put them up. Because actually I found one that was, I think it wasn't Zora Neale Hurston, it might have been James Baldwin, or it was one of those other great authors and everything, and it was done from like 50, 60 years ago. So it is a great way to find some information. But as we all know, when you got that much information, it's like going into a big library. You're hoping that you can find it soon, and sometimes it takes you forever to find it versus that soon aspect. But I don't know whether David, Rob, and Donald agree with me, but that's just some of my thoughts about cloud computing.
Thank you, Professor David.
Well, the comments have all been interesting, and the examples that Donald gave were really good ones. I personally see that the gap between cloud computing and virtualization is really narrowing to be almost no distinction, with the exception of some very large database servers and other things like that. Uh, Almost every server in a data center in the cloud has virtual machines right now. So virtualization is really what has enabled cloud computing to work so well. And so they really began to come at the same time. Uh, and, uh, virtualization is a technology that allows you to manipulate the hardware, but yet maintain its separate ability there. Uh, and, if I go back to the early days of the large data centers, every server was a dedicated server with its own environment. And you would have Windows servers, you'd have Unix servers, uh, and you actually even had uh, servers running the server version of OS 360 from IBM mainframe days. So you saw those in the data centers and how they were used. But one of the big advantages of virtualization in a cloud is it reduces the number of hardware servers you need by rather dramatically. And it lets you have a ton more flexibility. In my development environment on our virtualized servers, we think nothing of spinning up 2 or 3 or 4 test environments. We think nothing about really spinning up uh, different environments that we can use as sandboxes with potential partners or new customers to create these sandboxes. And in many instances, all of those are running just on 1 or 2 physical servers. So its impact on businesses is huge. Uh, Also, with the way we use virtual machines in our clouds, it really helps us with business continuity because we do something called a bare metal backup, where it's independent of this of the operating systems because of the way we use our virtualization. In the early days, that was really hard to do, where every server was by itself and sitting there and doing that. And it lets you have multiple operating systems on the same box. So I can run a Linux version. I can run like a Red Hat version. I can run a Microsoft version, all at the same time on the same hardware, but in different virtual machines. And that's really good. It also is both, particularly Donald talked about, as I spoke earlier, is it lets you encapsulate your data, and it gives you isolation because the physical server is isolated from what you're doing in your virtualization in your virtual machine. One of my hopes and desires, and Sharif, this might be one of the things that some of the startups in Malaysia or others could really put their arms around. I'm waiting to find an easy to use virtualization that I can install on my smartphones, on my iPhone, on my son's Android phone. I would love to, on my iPhone, set up a virtual machine that has nothing but my social media in it, because I really want that isolated from the banking apps I have on my iPhone. And I really want that isolated from some of my other communication apps. And I know the government has set up virtual machines on their high security phones. I want to see that coming to me as a end user too, because the concepts we're talking about in the cloud of all these benefits of separating it, being able to run different environments on it, being able to encapsulate the data, the extra security that Rob talked about earlier. I want to see us extend beyond the data center, beyond the cloud. And I would like to do that on my mobile device. I can do that on my notebook. I can do it on my desktop without a problem today. But I would love to see it extended to my mobile device, because this power virtualization has really helped us reshape an industry. And this virtualization is really what brought the benefits of cloud computing down to a cost affordable basis where almost anybody can set up virtual servers today. Uh, Even on my own home domain here, I have virtual servers for my home domain, much less my work domain set up in the cloud that I can use multiple ways. And depending what I'm trying to do, I can spin up other virtual machines, even on my home account, and become very much more productive. I can run experiments there. If I want to look at the security, for example, of Rob's or Donald's system, I would just spin up a new virtual machine, put my testing tools in it, do a totally different type of IP address that can only be traced to that virtual machine, and run the test against them. And then when I get the results, I would just blow that virtual machine away. So it also makes it harder to trace me as well. So those are some of the other things with it, Sharif. But if I'm a startup in a country and wanting to put things out in the cloud, the use of these virtual machines is going to make it faster for me. It's going to lower the cost significantly versus doing it as a traditional hardware server stack. And it's going to let me have the flexibility to get my speed to market faster. And I can duplicate environments very rapidly. It helps me get my speed to market faster. So these are all some of the other benefits of that virtualization tree.
And then I mean,
Thank you, Professor Rob.
we had people.
Right. Well, we have an interesting
Question.
in the chat having to do with Proton Mail. I'm not sure that has a lot to do with it. It's a cloud email service based out of Switzerland. The question is Proton Mail safer than Google Mail Cloud? Generally, any company that predominantly makes its money out of selling information on users should be considered inherently unsafe. And they may not be. I'm talking about Google here. Certainly the environment could be as secure as any other, but if there is a breach, you have to consider how you would defend that you use that your choice to use them was a well-measured decision and not based on some other factor. And that would be very difficult to do with Google because of the nature of their business. You would assume that they would be more permeable and more open to attack. And so if there is a breach, it just affirms that vulnerability and you would be exposed. And so from the standpoint of reputation protection and career security, I would tend to move away from any service from any vendor that largely lives on selling information, because it would seem a breach would be far more likely. So in that case, Proton Mail doesn't have that particular vulnerability, also based in Switzerland, where the laws are a bit stricter with regard to privacy. So you would think, at least on paper, that it was more secure. And at least in the head-to-head comparisons that I was able to review while I was waiting for my turn, it does look like Proton Mail is better. Be aware, though, that like anything else, when you're dealing with a mail service that's located offshore to where you're located, the laws and differences of that particular geography will probably prevail. And so you want to make sure that they are in compliance with whatever your policy is. From an individual standpoint, obviously that doesn't really matter, but companies make a big difference. I'll give you an example. A few years back, I was on a panel and we were talking about breaches, and the guy next to me shared this story about two guys in a pharmaceutical company who had gone to do some analysis on a new drug, a high-profile drug for the firm. And they went to IT and they asked for IT's help, and IT told them they could spin up a couple specialized workstations in about 6 months for a cost of somewhere between $100,000 and $120,000 to do the work. And the two researchers said, I can do this in the cloud. And so they did it in the cloud, and they were able to complete the project in a couple weeks, certainly well before they were going to have the hardware from IT, and at a cost of about $3,500. So $3,500 versus $100,000 to $120,000, 3 weeks versus 6 months plus 3 weeks. looked like a clear win. And they got an award. They got an award from the company for saving as much money as they did. And the following day, they were fired for cause. And the reason they were fired for cause is the service they used, the cloud service they used, the servers were located in Eastern Europe. And when security went to look for the records to make sure that they were secure, they could not find them. The service had moved those records and analysis off someplace else, and undoubtedly some other competitor in Eastern Europe now had them, and that violation of security cost those two guys their jobs. So on one hand, they saved a ton of money. On the other hand, they're unemployed and probably unemployable in their field, because when you have that kind of a breach with that kind of a problem in the pharmaceutical industry, no pharmaceutical company will touch you with somebody else's 10-foot pole, let alone anything in their own HR department. So it kind of showcases there is a risk to web services, and you do need to understand where they are. Now, in terms of the cloud, the major cloud services, whether we're talking about the ones based in the US or the ones based in China, are similar in capability. But when it comes to security, often these services focus a great deal on ease of use, and security as a result is subordinated to that ease of use requirement. The IBM is probably the only one that's different in this space, only because their cloud, not only is it already anticipating quantum computing based hacks, it's specifically designed to be secure. So in the IBM cloud case, security comes first, ease of use comes second, and their service promotes a hierarchy, a cloud hierarchy, which starts with on-prem, cloud, and then their secure cloud on top. And what they sell is being able to manage that mess seamlessly and easily, so you have the right service for the right type of project, be that on premises, be that in the cloud, or be that in a secure environment in the cloud, to make sure that the stuff that you're doing is secure. And environments that require that extra heavy security are typically defense, pharmaceuticals, medical. Those are the three areas that consistently provide require a much higher level of security. You would think others might, but often budgetary requirements, because security doesn't come without cost, does dictate a lower level of security. That is, until there's a breach, in which case things tend to get shuffled. So so on the question of Proton Mail, yeah, it's arguably safer than anything Google does. And one of the problems that Google has had with their cloud service is not the technology. The tech they have is good. That is the fact that people just don't trust Google to keep their information safe, and they recognize that if Google has a breach, it's going to be very hard to defend the decision to use their service because of the nature of Google, and that's why most rotate over to Azure or AWS as more successful services with a much higher focus, at least inherent focus on practices that would be by nature more secure.
Mm-hmm. Thank you, Professor Donald.
I love a couple of things that David said, which I forgot to mention or didn't necessarily forget, but one fascinating thing about it is imagine that you have a company with 500 people, and every night you want to back up every single solitary computer. Now, how do you do that? You can do it on the network. You can have a network where it goes out and it backs up every single solitary computer. But as we say in the business, that's fraught with peril. There is 500 computers where you can have a network problem, and even on this show, if something goes wrong with at least one, at least almost one of our people every single time we have a show. So but with a virtual system, all of the computers, all of the systems are on a small number of computers relatively, and so it's possible to just go and back everybody up by just they're on one computer, so you can just back everybody up really easily. David mentioned another thing that I think is kind of fun, which is oftentimes people are tracking you using IP addresses. So for instance, you download some software and they say you can use this for 30 days and then it expires. And one of the ways that they know that is that they hide some information about your computer, your IP address, the MAC address, some other information about your computer. They hide that in the registry and other places on the computer. It's difficult to track them all down. So when you, after 30 days, when you go and use it, it won't let you use it anymore. So all you do is just fire up a virtual machine, and as far as it's concerned, you're a different computer. So you can do that as long as you want. If you have some reason to want to use some software for free for as long as you want. So there's there's one fun thing you can do with it at least. Of course, a not so fun thing that's done with it is when people are trying to spam you or break in and do different kinds of things like that. They look like different computers every time they're doing it, and it makes it impossible to trace which computer they actually are, because they're different computers every time they do it. As far as when you look at them and you're trying to trace what they are, there's kind of ways you can kind of guess, but it's much harder. One thing I didn't point out is that you're using cloud services all the time when you use your phone, and so keep that in mind, because your phone, my phone at least, is backed up frequently, and that's backed up to a virtual machine, a virtual data store. I mean, my phone isn't backed up in the same kind of place as yours. So what I was talking about separate data stores, every one of our phones is backed up into its own virtual machine or virtual data. And that's a use of it that you no matter what are probably using every day. One other thing I just want to mention, people have been covering it very well, but one other thing I want to mention that's kind of interesting, especially for the developing world, I know for the United States, 6% of the people don't have access to internet that's good enough for them to be able to use broadband. There's no broadband connections. And so all of this doesn't work if you don't have a broadband connection. You probably have a decent broadband connection on your phone, but even that, there's a lot of places that don't have cell service. Even where I live, there's lots of dead spots where I don't have cell service at all. And so that means that, 6% of people, all of this doesn't work for them. And in the world, that number is much, much higher. So as we do this, and we rely more on the cloud and virtual machines, we're also kind of disenfranchising more and more people. We're making it so that more and more people can't really use computers. And that's something we should really mind, because it's without, I mean,
Donald, we can barely hear you. Now you're just kind of a whisper.
Okay, all of us. Oh, sorry about that. All of us can. What I was saying is that
Actually, it's on YouTube.
Oh, and it's just going to echo. I think I should just forget it this time. I ordered a new headset. I don't have any idea why my headset was broken when I woke up this morning, but I don't really have much more to. I can. Everybody's covered it so well that I think I'll just sign off for today.
Thank you. Professor David Smith, what's your concluding remarks for today's session?
Well, Sharif, Donald actually said it well. We've covered this topic reasonably well today. And to me, the benefits of using the cloud, and the cloud wouldn't be there really without virtualization today, are really straightforward. And as I said earlier, where I see what we've learned by the virtualized cloud is that we need to begin to virtualize other devices as we go forward too. Now, we've talked about Internet of Things, and we're now talking about Internet of Things clusters, which are at the edge of cloud, and we're seeing virtualization going to the edge of cloud and being used for things like Internet of Things clusters and others. Some of the streaming technology we're seeing being pushed to the edge of cloud as well. And virtualization there and connected virtualization, or what's called federated virtualization, is going to be very important as you see the movement towards increasingly more edge of cloud uh, computing capabilities. Uh, we're also seeing that the virtualization has real positives for security. In some ways, it's particularly to go to the edge of cloud, there's more challenges in the virtualized edge of cloud environment going forward because of the way they are connected together. Originally, it was done with VPNs, and VPNs, I personally am becoming less and less thrilled with because of the ability to deal with them. But for some people, that is still an extra level of security that they might need. But to me, the edge of the cloud computing virtualization has been an important part of helping take us, as Rob said earlier, from Web 2.0 to where we are today with Web 3.0. And because of that, it's going to be here and we're just going to see enhancements. And as I've said, we're seeing it more and more go from the centralized cloud to the edge of cloud as well. And it has an impact on commerce, it has an impact on government, it has a big impact on the startup community because of the benefits it brings them with speed of innovation and cost. Sharif, thank you.
Thank you, Professor Rob.
Yeah, a couple interesting things with regard to virtualization that are going on now. I mentioned earlier that there has been an industry push to kind of go back to that mainframe construct where somebody handles everything centrally, and you only deal with doing the work that you need to do. You don't deal with you don't have to deal with all the administrivia of trying to maintain the hardware. Two things with regard to the cloud that have been historic problems. That's been bandwidth and latency. And one of the services to look at to see how we've advanced or addressed those problems is NVIDIA's GeForce Now, which is a cloud gaming service. With gamers, latency is a huge problem, as is bandwidth, because you want the best experience that you can get, which requires a lot of bandwidth and relatively high resolution. And especially if you're doing a first-person shooter, you win or lose on twitch skills. And so how fast you can fire versus the other person. And so latency is a huge issue as well. And so with GeForce Now, you can see the progress that the industry has made to address both problems, because many of the top tier games are available on that service, and they play very much like if you were playing them on your own machine at home, assuming that you have a decent internet service, which, as Donald pointed out earlier, not everybody does. The other service that is spun up is Windows 365. Windows 365 is a cloud instance of Windows. Again, you would run it's where your Windows instance runs in the cloud, not on your desktop. It's maintained by Microsoft. That entire environment is supported and secured by Microsoft. Again, you don't really worry about any of the patching, any of the updates. That all happens automatically and remotely. And all you worry about is doing your work. Again, it's a showcase of both bandwidth and latency, because if you've ever tried to type a document where you have high latency, it's a little annoying because you'll type 3 words and then take a breath and those 3 words appear on the page. It can get very annoying. But bandwidth and latency issues have been improved so much that the last time I used it, it was very much like I was just running it on my own machine. I did notice a slight performance lag, but it was in a fraction of a second. Certainly not seconds, and very usable, even in my remote case. And so the industry does seem to be moving pretty heavily, thanks largely to the pandemic, to really favor virtualized cloud environments. And the And the reason for that is during the pandemic, nobody was going into the office, including the people that were supporting the infrastructure, which made it problematic for those people that were remote, because if you had a major outage, who were you going to call to fix it? Those people had to come in from wherever they were into an environment that had been identified as already being unsafe to do some work, and clearly they didn't want to do that, and things weren't getting fixed timely. So by using cloud services, then somebody else did that for you. Those people were coming into work, or at least the services were altered so they could do much of their work remotely. And the end result is people stayed up and remained running. You didn't have to worry about IT staff going anyplace because it's being handled by somebody else. And the only thing you did have to worry about would be major catastrophic weather or technical events that might take down the entire service. And we did have a few of those. But it was minor enough so that what was a relatively slow march from on-premise to hybrid to cloud became a very fast march to cloud. And now pretty much all the focus is on cloud, with this hybrid concept, this concept of blending on-premise and cloud being more of a legacy transitional concept as opposed to being one that was sustaining. So the market's changed a great deal thanks to the pandemic, and some of it may eventually come back. The industry does ping pong quite a bit between these constructs, and has historically. And for instance, right now we're talking about moving computational performance more closer to the edge to solve bandwidth and latency issues that have been identified as a result of a major push to centralize everything, which created a different set of problems that we're now addressing by moving some of the computing architectures closer to the users that use them, but not necessarily all the way to the desktop, depending on the implementation. So it's the world as it exists today is far more fluid than it was, with a heavy emphasis on shifting to cloud services and away from maintaining your own infrastructure in favor of having computing as a service. So it's an interesting, fast-moving time of change.
Thank you, Professor Donald. What's your concluding remarks?
Paying attention to you, cares about you, and just wants
Mr. Donald.
She was big inside and find the passion that was deep within me.
vibrant energy.
You can't really hear me. Can you hear me?
One of the things that I have to have her coach.
No, we can't hear you, Don.
Yeah.
I think Don is out.
Okay, understand. Mr. Markley, what's your concluding remarks for today's session?
Well, as y'all can tell, the great thing about all of this virtual and everything else is that hopefully it will help us as we multitask. Because as always, I'm multitasking, because definitely doing your show, and it's always great to do your show, and you're doing some amazing things with your show and all of that. But we've also got Barbara H. Smith talking about empowering people and all along those lines. So I'm producing and doing that, and maybe eventually Donald and the rest of the guests that are here, yourself included, can help me find a robot so that I can be able to do this and have the robot to do the other tasks as well. So that's what we need, is to have like 2 or 3 marks and all of that. But definitely it's been an amazing conversation. I do know that a lot of people are looking at different styles of mail, whether it's Google Mail, Proton Mail, or a number of others. And as I stated earlier, a lot of people are trying to figure out how they're going to deal with safety within that context and all along those lines. So definitely that is something that is going on and all in that world.
Thank you everyone for joining today's session. Tomorrow we have special episode and we have debate. Professor Rob, you can go for government, and Professor David Smith for oppositions. We already shared the topic and everything, so hopefully tomorrow's debate will be very helpful for our audience. Thank you everyone for joining today's session. Thank you, bye-bye, and take care.